Did you know that scientists use X-ray vision? I don't mean the type that Superman uses. I'm talking about the X-rays we shoot at different materials to see how they're structured. When you shoot some X-rays at a material, PDF does a bunch of math to give you a pretty graph like this. No, not the document file type. I mean paired distribution function. Here are 7 things a PDF pattern can tell you.
Let's start with the PDF pattern of table salt. If we look at this pattern, the first thing we can look at is the peak position, which tells us the atomic distances between different atoms. If we look at the area under these peaks next, we can see how many neighbors an atom has and how close they are to one another. Some may be next door, while others are down the block. The next door neighbors give us a number called the coordination number for the atom. This number helps us see which type of crystal structure a material has. In this case, the structure is cubic. What does it mean if the peaks shifted? This means the material undergoes thermal expansion, which is when the crystal lattice of the material either expands or contracts upon heating. In the case of our salt, if we heat it to 600 degrees Celsius, the lattice expands and the atom distance increases. Therefore, we see the peaks shift to the right. Sometimes, instead of shifting, the peaks will become wider upon changes in temperature or pressure. The broadening of these peaks is due to the irregularities in the crystal lattice, such as atomic disorder or defects. PDF can also tell us the size of the particle by looking at something called the Rmax. This number refers to the maximum radial distance of a material. Let's look at the titanium dioxide nanoparticle for example. Notice how the peaks start to get shorter as we move further down the pattern. That's because the Rmax is within the range of a nanoparticle. For this nanoparticle, specifically, the diameter is 3.5 nanometer or 35 angstrom. PDF can also give you a phase analysis of your material. Here is an example of 2 TiO2 polymorphs, anatase and brucite. Both are nanoparticles, but they have different sizes and crystal structures that are formed under different conditions. If we look at this PDF pattern, we can see it contains different amounts of both polymers. Finally, we can also see how 2 different materials mix together and whether or not they are mixed properly to give the desired result. Here you can see the PDF of TiO2 and silver nanoparticles. They are very different patterns. Then after mixing them together, you can see how the PDF pattern has elements of both materials, which shows us the formation of a nanocomposite material.
Well, there you have it. You've learned 7 things PDF analysis can tell you about a material. So next time you're looking at PDF, remember the acronym ANTI-SPAM. Thank you for watching, and don't forget to like and subscribe.